One important study in chemistry is the study of calorimetry. Now, calorimetry is the study of the measurement of heat flow, or it's a technique that enables you to measure heat flow. What it allows you to do is study something called heat capacity, so the amount of heat required to raise the temperature of a material by 1 Kelvin. And I'm going to go ahead and write here, this is equal to 1 degree Celsius. Okay, so how much heat something can endure before it changes temperature by 1 degree. Molar heat capacity is a specific quantity, the heat capacity of 1 mole of a substance. So how much heat is required to raise 1 mole of a substance 1 degree Celsius or 1 Kelvin. Now, specific heat or specific heat capacity is the heat capacity of 1 gram of a substance, and how much heat is required to raise 1 gram of a substance 1 degree Celsius. Now, specific heat is a good source of questions that you can look for. Now, specific heat, also written as SH, is equal to Q, your heat, divided by the mass of a substance and the change in temperature, delta temperature. Okay. Temperature. Yeah. Now, those are all these different things that I've defined already. One standard that you should generally kind of look for is the the specific heat capacity. Is the specific heat capacity of water. So the SH, I'm going to write subscript H2O, is equal to 4.184 joules per gram degree Celsius. You'll also see the units as joules per gram Kelvin. Okay, so on what that means is that you have to input 4.184 joules to change 1 gram of water 1 degree Celsius. Now, we'll have a number of different practice problems that you can look at over this, and there will be some sapling questions and exam questions that relate to this. But keep that standard in mind, that 4.184 joules per gram degree Celsius. Okay. Now, a good practice question here is the specific heat of ethanol, and this provides our specific heat capacity or specific heat of ethanol as 2.46 joules per gram Kelvin. How many joules of heat are required to heat 193 grams of ethanol from 19 degrees Celsius to 35 degrees Celsius? Okay, so you might look at this and think, oh, there's a typo, but in fact there is not, because remember, when you look at temperature in Kelvin and temperature in degrees Celsius, the delta T, if you're looking at change in temperature measured in Kelvin, well, 1 degree or 1 Kelvin is equal to a delta T measured in degrees Celsius of 1 degree Celsius. So if the temperature rises 1 degree Celsius, it's also gone up 1 Kelvin. Now, the magnitude of that is a little different because whenever you're talking about a temperature in Kelvin, T sub K is equal to 273.15 plus the temperature degrees Celsius. Okay, but here, all that we really care about, if we look back at our specific heat equation, SH equals Q, our heat divided by M delta T, well, our delta T is going to be the exact same whether these units for temperature were recorded in Celsius or Kelvin. Okay, so to solve this problem, all that we really need to do is we need to look at what are our definitions. So our specific heat capacity, has that been provided? Yes, it is. It's 2.46 joules per gram Kelvin. Okay, now I'm going to go ahead and make it simple on myself, and I'm just going to go ahead and change this to degrees Celsius, just so I don't mix anything up. Okay, now my mass. What is the mass of this substance? Well, I'm talking about a mass of ethanol, and the mass of ethanol is 193 grams. Okay, and then finally, what is my delta T? Well, my delta T is going from 19 to 35 degrees Celsius. So that's a change, a delta of 16 degrees Celsius. Okay, now what I do not know is my Q. Okay, so what I'm going to have to do is I'm going to have to take this equation right here and basically rearrange it to isolate that Q. And that's actually going to be kind of simple to do. So what I will do is I will just rewrite this as SH divided, or I'm sorry, SH, I'm going to multiply each side of this equation, m delta T, because then that's going to cancel out there, it's going to cancel out there, and I'm going to multiply it by my SH, so m delta T. Okay, so I'm going to be left with an equation that looks like this. M delta T times SH, I'm going to put these in parentheses just to keep it all straight, is equal to Q. Okay, because that's what I'm looking for. Now, one thing I want to keep track of, just to be on the safe side, is my units here, joules, how many joules. I didn't get mixed around with any kilojoules or anything like that. So I'm going to plug all this in. I'm using my phone as my calculator. So plug all of this in. My mass is 193 grams times my change in temperature is 16 times 2.46. Okay, and that's going to be 7,596.48. All right, so my Q for this is that right there. My units for this, sorry, I should have given myself a little bit more space, is going to be in joules equals, I didn't give myself much space there. Oh well, let me correct that. Now what that means is that you're going to have to add this heat to this reaction. Okay, so that's going to be a positive 7,596.48 joules. I hope this was helpful. Thank you very much.